Welcome to the lesson on radian measure. So the radian measure is a different way to express an angle. Usually we express an angle in degrees, but there are more than one ways to express an angle. So that means radian measure and degrees are similar in that they describe the same thing, but it's a different language, it's a different way to express the angle. So here are the conversions to convert between radians and degrees. So 1 radian is equal to 180 over pi. We also have 1 degree is equal to pi over 180, which means we can find what it is in radians if we had 180 degrees, and that would be pi. And if we had 360 degrees, that's 2 pi, which is also 1 revolution. And 1 revolution also just means that you're going all the way around once. In this enclosed box, I have the rule to convert between radians and degrees. So if you want to convert an angle into radians, you just multiply the angle with pi over 180. If you want to convert the radian measure to degrees, then you multiply it with 180 over pi. So let's do some examples of converting back and forth between degrees and radians. So let's just say that we have 255 degrees. We want to find its measure in radians instead. According to our rules up here, it says to convert to radians, multiply the angle with pi over 180. Which gives us 255 pi over 180. But we could also simplify this fraction by dividing the top and bottom of each fraction by 15, and we would get 17 pi over 12. And that is by dividing top and bottom by 15. So usually we can express a radian in terms of pi if we are going to not figure out what it is using a calculator. You can leave it into terms of pi, or if you had a calculator, then you can go ahead, do 17 divided by 12 multiplied by pi in your calculator to get a numerical answer there. So I'm just going to leave it for now because most of the time we are not going to use much calculator in this unit. So I'm just going to leave it as a fraction in terms of pi. Moving on to the next example, we are given an angle in radians and we want to convert it into degrees. So again, looking at our boxed in area with our rule, it says to convert to degrees, multiply with 180 degrees over pi. You can see that your pi is going to cancel out. So we have 5 times 180 and then divide that by 7. And you can go ahead and use your calculator for that because when we express our measure in degrees, usually there are decimal places there. So this would be negative 128.6 degrees. For the next one, we are given radians, which is negative 8.25. And we want to convert it to degrees. So that's multiplied by 180 over pi. And we just plug and chug in the calculator for something like that, which is negative 472.7 degrees. Would be the same thing as negative 8.25 radians. Next, we're going to convert revolution to radians and also from radians to revolution. So let's do this one first. We know that 1 revolution is equal to 2 pi. So then I'm going to multiply both sides by 0.87. And then we're going to have 0.87 revolutions on our left-hand side. So that's 0.87 revolutions. And then I'll calculate 2 pi multiplied by 0.87. This is 5.47 and that's still in radians. This means that 0.87 revolutions is the same thing as 5.47 radians. And then we're going to do the other one here. Again, we know that 1 revolution is equal to 2 pi. In this case, I want to manipulate the pi side. So I'm going to divide both sides by 2 pi so that I can get a 1 on my radian side. That's 1 over 2 pi revolutions is equal to 1 radian. Now, for our radians, we want it to be 5 pi over 4. So now I'm going to multiply both sides by 5 pi over 4. So we have 5 pi over 4 radians on our right-hand side, and then going to multiply this out. Our pi will cancel out here, so we're going to be left with 5 over 8 revolutions. So that means 5 pi over 4 radians is equal to 5 over 8 revolutions. So you can go ahead and do it to try it yourself, and then when you're ready, press play for the solution. So to convert 170 degrees to radians, we're just going to multiply by pi over 180, which is 17 pi over 18 pi, 17 pi over 18. And if you want to figure this out in terms of a decimal, then you can plug it into your calculator. It would be 2.967. For the next one, we're given an angle in radians. To convert to degrees, I'm going to multiply by 180 over pi. Your pi's are going to cancel out. And again, because we're converting into degrees, we do want to go ahead and put it in the calculator and not leave it as a fraction. So if we do a negative 12 times 180 divided by 11, we get negative 196.4 degrees. The last thing we're just going to look at is memorizing your exact values, but this time in radians instead of degrees. So here again is your unit circle. But with the degrees, beside it is the equivalent angle in radians. So we have 0 degrees is equal to 2 pi, 30 degrees is equal to pi over 6, 45 degrees is equal to pi over 4, 60 degrees is equal to pi over 3. These are the ones that you do need to remember. You have to remember the relationship. And then afterwards, it's a little bit easier. There is a pattern. So once you're in quadrant 2, the pattern I like to think about is that the numerator is 1 less than the denominator. So that's why we have 2 pi over 3. Again, 3 pi over 4, because the numerator is 1 less than the denominator in quadrant 2. In quadrant 3, we have a numerator that's 1 more than the denominator, so we have 7 pi over 6 and 5 pi over 4. That's one way to remember the angles in quadrant 3. And then in quadrant 4, I like to think the denominator times 2 minus 1. If you're still into remembering in some sort of way, you can obtain the numerator from that way. So what can say it's like 6 times 2 minus 1, which is 11, and that's how we remember that's 11 pi over 6. Also, with your 2 exact value triangles, you can remember them as well in radians. So pi over 6 is the same thing as 30 degrees. Pi over 3 is the same thing as 60 degrees. Pi over 4 is the same thing as saying 45 degrees. So it's the same triangle, but again, we're just remembering this in terms of radians instead of degrees. So also, take the time to remember your exact value in radians. If you have to redraw this several times so you can remember those angles in radians, then please do that.